What's up everyone, Patrick here, welcome back. And in this video what we got to do is we got to find the union and intersection of these sets here. So notice this first question, we have two sets. We're going to find the union and intersection between these two sets. And then here the second question between these two sets, A and B. So let's start off with this one, number one. So notice that A, we have this set 1, 2, 3, 4. Notice that this set is in roster notation. Also notice that this set here is a finite set, right? There's a finite amount of elements in it. Now this one, set B, X is an element of integers and X is between 3 and 10. So notice that this set here, set B, is in set builder notation. And so personally what I like to do if possible is I like to take any sets that are given in a complex way. Notice that this set, it's given in a more complex way than this one, and see if I can simplify it a bit, at least visually, to see how I can represent it. And notice that this set B, because it's just the integers that are between 3 and 10, right, not inclusive of 3 and 10, notice that we can just take that and write it easily in roster notation. So basically set B, another way to write it is basically 4, 5, 6, 7, 8, and 9, right? All the integers that are between 3 and 10. So this set and this set, they're actually the exact same thing. And in my opinion, this one is just a lot easier to look at. And it's a lot easier to work with when you're going to be finding the union and intersection of this and this. So that's the first thing I always do. I always look at the sets and see if I can write them in a more simple format. Now you got to be careful with these signs here. If this was like less than or equal to 10, then there would be a 10 over here. It would be inclusive of the 10. But because this was greater than 3 and less than 10, the 3 and the 10 are not included. Another way this could have been written here is, 9 over here, like that. Right? This here could have been here, and it would have given us the same set. All right, so now it's a lot easier to find the union and the intersection. I'm going to start off with the intersection. Usually I start off with the intersection first. I feel like it's a bit easier to get. It's usually less restrictive than this one. It's not always easier to get, but in this case I feel like it will be. All we have to do is look for the common elements. And what are the common elements between 1, 2, 3, 4 and then 4 to 9? Well, it's just the number 4, like that. Right, that's the intersection and it only has one element. And then the union, it's got to be in both, right? So it's in A or B. Sorry, it doesn't have to be in both. It could be in A but not in B. It could also be in B but not in A. So it's less restrictive, so there's going to be more elements. So basically it's, notice how this is the integers 1 to 4. This is the integers from 4 to 9. So it's basically going to be all the integers from 1 to 9. Yeah, like that. That's the union, A or B, right? Which elements are in A or B? This one is which elements are in A and B. And then this one here, perhaps if this was a multiple choice test, you got to be careful. Sometimes they'll give this set, remember the union is just a set itself. Maybe they'll give this in a different notation. So notice how we could take this and we can put it in different formats. We could say X is an element of integers between 1 and 9. Right? That's one way to write it. Notice these are all natural numbers as well. So another way we could write this is we could say X is an element of natural numbers where X is less than or equal to 9, or X is less than 10, not inclusive of 10. Remember, natural numbers, they start at 1. So all the natural numbers starting at 1 but less than or equal to 9, that would also be this. So you got to be careful. Sometimes these sets, they could be given in different formats. All right, so whichever way you put the union, these are a couple examples that you can represent it as, and then this here is the intersection. And then number 2, this one's a lot easier to work with. Both of these are in roster notation, so we got 0, 2, 4. And then over here we got 3 over 2 and 5 over 2. So the union between them is basically, notice that you don't have any common elements. So it's just going to be 0, 2, 4, 3 over 2, and then 5 over 2. It's not necessarily in order. You don't necessarily have to put it in any order. Remember that sets can be sets are an unordered list of elements. So you can put them in order. So like the 3 over 2, 1.5, you could put over here. But this here is the union between these two. And then this is tougher to put in this set builder notation because we have different kinds of numbers. Here we have integers, but then over here we have rational numbers that are decimals that terminate. This is 1.5, and then this is 2.5 right there. So I'm just going to leave it in that roster notation. Now, what's the intersection between these? Notice they don't have any common elements, and so what you would say, this is an empty set. So there's different ways to show this. You show it as a 0 like that, or another way to show this is just empty brackets like this, right? This is called the empty set, meaning there are no elements in it, or sometimes it's called the null set, right? So there's no common elements, so there's no intersection, there's no elements in the intersection set. So you could represent it like this, or you could represent it like this. Don't, be careful with this, don't represent it like this, right? Because 0 is a number, and it would be that set there has one element, and it's the number 0. So if you put a 0, there's no brackets around it, just a 0 with this line through it, or you would put empty brackets around it, right? So that's how you do that, finding the union intersection between these sets.